Welcome to the Microsoft Certified Azure Administrator Associate training course. Let me briefly introduce myself as an instructor. I have experience in developing the enterprise system and the cloud architectures for some major companies. Besides this course, I offer tutorial on cloud services and programming on Udemy and YouTube. I also offer courses to prepare for other Azure certification exam and tutorial on other cloud services like Google Cloud and AWS on Udemy. This course is dedicated for those who want to pass the Azure Administrator Associate exam. It covers key points that will appear on the exam and includes about 6 hours of the video explanation. It covers all the services within the exam scope. With hands-on videos, you can engage in practical learning. And I also provide some sample questions for you. In closing, I sincerely hope you pass the exam and elevate your skill further. Thank you for listening. In the YouTube version of this course, it includes the presentation services within the exam scope. For a comprehensive course that includes a hands-on and practice tests, please visit my Udemy course. Check the description for the more detail. So let's start it. Welcome to the AZ-104 Azure Administrator Associate training course. This course is divided into 4 main sections. In Section 1, Microsoft Certification Exam and Preparation, I will introduce an overview of the exam and some tips on how to study for it. And Section 2, Introduction to each service, I will cover all the services that come up in the AZ-104 exam. And Section 3, Practice Question, I will provide the insight and the guidance on taking the exam. And lastly, in Section 4, a summary, I'm going to introduce additional learning resources. Alright, let's delve into Chapter 1. In this session, I'm going to introduce an overview of Microsoft Azure, the detail of the certification exam, and how to set up an account. First off, let's talk about what Azure is all about. The Microsoft Azure is a cloud service provided by Microsoft. It is the second largest after AWS. They started the business in the late 2000s and changed its name to Microsoft Azure in 2014. As of now, they offer more than 265 different services, with new service being released every year. And these are examples of Azure services. There are more than 260 services, so this is only a partial. Not only infrastructure as a services, for example, virtual machine, storage, and networking services, but also they offer services such as gaming, AI, machine learning, and so on. In Chapter 2, I will introduce the major services that appear in the exam by each categories. And this is the share of the cloud market. For the past several years, AWS has been the first place, Azure in the second, and the Google Cloud in third. AWS and Azure account for more than half of the total market share. Azure has the 26% market share and is expected to continue to grow in the market. You are well worth learning Azure. And this is a comparison between cloud and on-premises. One of the primary advantages of the cloud service is the ease of deployment via internet. Also, you pay for what you use, which often means a reduced cost for the user. But the benefits of the moving to the cloud are not just about the cost saving, The standardization at the infrastructure can also simplify the management. And lastly, for your reference, I'd like to introduce the comparison chart for the three major cloud providers given by Google Cloud. All three cloud providers offer similar services. If you have experience with Google Cloud or AWS, this comparison helps you understand Azure well. Next, I will introduce the overview of the certification exam. And before we start, I want to talk about something that might sound a bit preachy. You might see the people online comment like that I passed in just a few weeks, or I passed even though I am a beginner. But remember, the way of learning is different person by person. Your background, how fast you learn, and your personal and work life, all these things affect how much time you can dedicate to studying. It's important to find a pace that works for you. When it comes to studying, there is no one-size-fits-all approach to studying. A learning style is different by person, and the time needed to pass the exam is also different by person. Easy and hard are subjective and not just a universal truth. In addition, Roma was not built in a day. Engineering skills are built over time. The IT world is rapidly evolving, so there's no end to learning. Make the most of any free time and find a suitable way to keep learning. Earlier I told you that the way of studying differs from person to person. In this course, I will be breaking down the Azure service by category and after that providing the practice questions. Whether you want to dive into the lecture first or tackle the question is totally up to you. Thanks to platforms like Udemy, you can easily learn technology and business skills. And this means the more willing you are to learn, the more you can grow. The benefits of the on-demand learning include, as long as you have internet access, you can learn anytime and anywhere. And you can attend the lecture by popular instructors regardless of where you are. And it's flexible. You can adjust the playback speed and revisit the specific sections. The drawbacks of the on-demand learning include, unlike classroom, you may find it difficult to concentrate. Because the teacher-student relationship is one too many, it's hard to ask questions in real time. But in this course, I will try my best to answer your questions. Here is a list of Azure certification. Microsoft offers 3 levels of certification: the Fundamental, Associate, and Expert. The Fundamental exam is for beginners and it's a gateway to every certification. And the Associate exam is for intermediate level candidates with about 2 years of work experience. And the Expert exam for advanced level candidate with 2 or more years of work experience. The AZ-104 is categorized as the application and the infrastructure and includes a question on services such as virtual machine. The Azure certification expires at 1 year. And next, here is the flow of taking the exam. First, you need to create a personal Microsoft account. You need a personal account, not a corporate account. Second, to specify the date and location of the exam on the Pearson VUE. You can also take the exam remotely. And at the exam site, you will be required to bring an identification to complete the entrance procedure. You don't need writing material for the exam because there will be no calculation questions. The result of the exam can be checked immediately on the site. If you fail the exam, you can take it again after 24 hours. If you fail the exam a second time, there is a 2-week interval before you can take the exam a third time. In addition, you may take the test at the most 6 times in a 12 months period for the fairness. At the associate and the expert level, the certification is valid for only 1 year, so you must renew your certification. You will be notified 6 months prior to renewal. But renewal process is not difficult and you can take it online. Next, I'm gonna introduce AZ-104 exam guide, and the current exam guide is dated January 2024 and recommend you review it before taking the exam. The audience profile is the administrator who is familiar with Azure services like operation system, networking, servers, and virtualization. In addition, Azure tools such as PowerShell, CLI, ARM template, and Entra ID. The scope of the question is described here, and this course is comprehensive and includes the exam content that will appear on the AZ-104 exam. The exam is worth 1,000 points and the minimum passing score is 700. The exam has multiple choice, drag and drop, hot area, and repeatable patterns. So there are multiple exam formats, but you don't need any special preparation. And since there is plenty of exam duration, you don't need to worry about the time limit either. It's not difficult to pass if you stick to the basics. And lastly, here is a sample question. This is a question in which you choose one of 4 options. I have prepared a practical question at the end of this course. Next, I will introduce the fundamentals of Azure. Here I'm gonna explain the management level and hierarchy, region and availability zone, and Azure Resource Manager. The first one is management level and hierarchy. I'm going to introduce the tenant and the subscription. A tenant is an instance of Microsoft Entra ID. It will be automatically created when you sign up a Microsoft Cloud service. A tenant is a single organization and its primary directory. It can be used to manage users, provide them access to resources, and manage subscriptions. The Azure Active Directory has been renamed Microsoft Entra ID since 2023. And next, a subscription is an agreement with Microsoft which provides you with a billing account for the services. It's essentially a logical container into which resources usage is reported, billed, and paid for. Each subscription can have its own payment method and policies with which you can organize the resource and manage cost. For example, if you are a corporate accountant, having multiple subscriptions for different departments makes it easier to manage payment. There are multiple types of purchase options. If you are an individual using Azure, you would use MOSP. If you are using Azure as a corporation, you would use the Azure InOpen, purchasing through the CSP, SCE, or EA. For your information, Azure's offerings are updated frequently. You can check the currently active and terminated plans on the official website. The Azure provides 4 levels of the management: the management groups, subscription, resource group, and resources. Management group help you to manage access policy and compliance for multiple subscriptions. These levels have the parent-child relationship. The policies defined at the management group level are inherited by its child subscriptions. And a subscription logically associates user account with the resources. Each subscription has its own set of quota. You can manage the cost and the resources on per subscription basis. And the resource groups are a collection of resources that facilitates the deployment of the resources such as application, database, and the storage account within Azure. A quota refers to the limit set on the resources you can consume within your subscription. For example, you can set 10,000 management groups per directory. A management group tree can have a root level and up to 6 additional levels. Each management group can only have one direct parent, but can have multiple child groups. Additionally, there are limits on connections, storage, and APIs. And for some cases, you can request quota increases. And these quotas are often changed, so you don't have to memorize them. But it's important for you to consider these constraints when you design and manage systems. And next one is region and availability zone. Regions and availability zone are very important concepts to learn about Azure. A region is a geographical area in which Azure provides services. You can access almost any region in the world as long as you have the internet connections. However, you should deploy your resources to regions that are geographically close to your users as much as possible. The services deployed in the region are called regional services, and the region-independent services are called global services. The Azure also has the concept of the region pair to achieve redundancy. A region pair is a combination of physically distant regions. For example, US East and US West are region pair. If data storage is stored in the region pair, and a failure occurred in one region, service can continue in another region. And this is for your reference. The Azure has several special regions: Azure Government in the US, Azure China, and Azure Germany are special regions. Due to local regulation, the 3 regions cannot be accessed without a special process. And next is availability zone. Availability zones are logical data centers within each region. There are 3 or more AZ within a single region. Availability set is a set of server racks that are set up for redundancy within the single data center. If hardware fails in the server rack, the service can continue in other. The Azure offers 3 types of redundancy configuration: multi-region, the multi-availability zones, and the availability set. And by the way, AWS and Google Cloud also have the concept of the region and availability zones. I will introduce the fault domain and the update domain. A fault domain is the logical group of underlying hardware within the Azure data center. The fault domain is the area where power supplies and network equipment are shared in rack. providing the redundancy in the event of a failure. An update domain is a logical group of underlying hardware that can undergo an update or maintenance activity at the same time. For example, the image shows the two update domain for each 3 fault domains. The service will continue even if the 2 of the 3 fault domain fails. Also, if one of the update domain is updated, service can continue in other update domain. Next, I'm going to introduce Azure Resource Manager. Azure Resource Manager, or simply ARM, is a deployment and management service for Azure. You will use ARM when you access Azure resources in any way. Because Azure is a cloud service, you operate it via the Internet. You manipulate resources on Azure via Azure Portal, Azure PowerShell, Azure CLI, and REST clients. On the following pages, I will introduce these tools. The Azure Portal is a web-based user interface for managing the resources. Azure Cloud Shell is an interactive shell within the browser. The Azure PowerShell is a module offering the commandlets to manage Azure through the Windows PowerShell or PowerShell Core. Azure CLI is a command line tool providing a set of commands, and the Azure Mobile App is a mobile application enabling the resources management from your mobile devices. The CLI and the PowerShell are outside the scope of AZ-104 exam, but I'm going to introduce them for reference. The Azure CLI, or Command Line Interface, and the PowerShell are both tools for managing Azure resources, but they differ primarily in syntax and platform compatibility. The CLI is often preferred for its simplicity and cross-platform support, while the PowerShell offers a more comprehensive scripting experience with advanced features and the ability to leverage the .NET framework. Here is a sample list of the CLI command. You can perform operation by typing the commands beginning with AZ. These commands are used to manage Azure resources. There are actually numerous commands available, and you can use the combination of resource name and parameter to manage resources. I'm going to introduce the element of PowerShell. The commandlet is a lightweight command used in the PowerShell environment. They are built-in command with the verb-noun syntax, like get service, which retrieve information about services. Script is a set of commandlet and logic written in the PowerShell scripting language, saved as the .ps1 files. The scripts can automate a complex sequence of tasks. And alias is a shorthand reference that you can use to call a commandlet. For example, ls is an alias for the getChildItem commandlet in PowerShell. The function is a block of code that performs a specific task and can return values. It's similar to commandlet, but created by the user for custom tasks. The function can accept parameters just like commandlets. Again, these commands are outside of the scope of the AZ-104 exam. However, if you are going to continue learning Azure, I recommend you to learn them. Currently, there is a classic deployment model called Azure Service Manager and a deployment model using Azure Resource Manager. If you are new to Azure, you do not need to learn about ASM, because ASM is scheduled to be discontinued at the August 2024. ARM is a deployment model added in 2014 when Microsoft Azure was named. With ARM, the resources can be grouped, which allows them to be deleted in one step. You can also use template, locks, tags, and role-based access in ARM. The Azure releases new services on a trial basis before releasing them to the public. These new services offer in preview status. These new services will be tested and feedback from the users before they become generally available. ARM templates are JSON files that define the infrastructure and the configuration. ARM templates consist of some sections. The schema specifies the versions of the template language. The content version defines the versions of the template itself. The parameter allows input of the value that affects the deployment's configurations. Variables are values used within a template to simplify complex expressions. Resources define the Azure resources to be deployed or updated. And the outputs return the values from the deployed resources, often used for the referencing in other deployment or outputs. From the following pages, I'm going to introduce each section. The parameter section refers to the parameter that the users can input when deploying the resource. In this section, you can define the data type, default values, the possible value, minimum, and the maximum value. And this sample defines the size of the virtual machine. You can set multiple virtual machine sizes as a parameter and establish a default value. The variable section is where you define the variables used within the template. For example, you would outline the virtual machine's name and setting, the storage account names, and the network-related configuration. In the resource section, you define the type of resource, name, location, properties, and so on. Here in this example, we have the type of storage account. The type specifying the kind of resource. The API version indicates the version of the REST API. And for some resources, you can set the SKU. And for storage account, you can define the type of redundancy. And the kind property sets the classification of the resource. And finally, the output section defines the value returned as the result of the deployment. It is used to retrieve the resource IDs and properties after deployment. The acquired resource identifier are used to provide the information externally. Next, I'm going to introduce Azure Bicep. When writing the ARM template, a domain-specific language called the Bicep is used. The Bicep aims to be more readable than JSON-based ARM template and act as the abstraction layer. When you deploy a Bicep file via CLI or PowerShell, it compiles into the ARM template. The Bicep extension can be installed in the Visual Studio. and previously the bicep was not included in the exam scope, but it is now. Just like with ARM template, you can answer the question by interpreting the text, as it is composed of simple words. Next, I will introduce to the creating an Azure account. I will provide several hands-on activity in this course. I think hands-on is not necessary to study for the certification exam, but from the practical point of view, I recommend hands-on practices. First, search for Microsoft Azure on search engine and go to the Azure web page. Then you will see the page like this, where you can create an account by clicking the Start Free. The website is updated frequently, but you will usually find the button at the top of the screen. Next, you will see the pop-up asking you to create a Microsoft account. You can create a new account from here. If you already have a Microsoft account, sign in with your email address or phone number. Azure often offers the promotion for free credit for first-time user. You may get $200 free credit. In this course, you can conduct a hands-on for less than $200. Once you have created an account, you can access to the Azure portal. From Azure portal, you can access Azure services and manage your account. When you create an account in Azure, it is automatically tied to your Microsoft Entra ID. Microsoft Entra ID provides the identity and access management. This is a unique feature of Azure and differs from AWS and Google Cloud. You can also add subscription and license to access certain services or for more advanced features. Next, we will set up a cost alert. You can learn this course hands-on within the free framework, but if you start up the resources for an extended period of time, you may be charged more than you should be. For example, if you start up a virtual machine and forget to stop it, you will be charged by the hour. Therefore, we recommend that you set an alert to be triggered when costs exceed a certain value. If you search for a cost in the search window, you will probably see the alert for the cost. Select Cost Alert from the menu on your left. By default, you will see no alert to display on this screen. Set an amount for the budget. In this way, an alert will be issued when the specified amount is exceeded. For example, if you enter $50, you will be alerted when the billing exceeds $50. You can specify your own email address for the alert method. And next, let's take a look at Azure portal screen. From the left to the right, portal menu, search window, information, and account information. First, click the portal menu. From the portal menu, you can create the resources, and you can register frequently used services as a favorite. You can search for various services from the search window, enter a service name to view a service pages, document, and more. From the top bar, you can see Cloud Shell, directories and subscription, notification, portal setting, support and troubleshooting, and more. The Cloud Shell is the command line interface that can be run from the Azure portal. You can run the command line in your browser without installing it on your own local PC. In this course, we will set up a resource group and create resources under it. By creating the resources in the resource group, you can delete all resources at once when the course is finished. For example, you can set up the resource group with the name Test Udemy. Click the menu in the upper left corner to go to the resource groups page and click the Create. And from here, you can create a new resource group. Specify the name and region. Since I am in Japan and I select the Japan region, you may choose any region because the service in this course can be used regardless of the region. By choosing the region that is close to where you use the service, you can access the service with low latency. So that's all. We will finish the setting account. I will introduce the services that will appear on the exam along with the service category. Especially monitoring, security, compliance and governance are the services that are mainly questioned in the AZ-104. Firstly, I'm going to introduce the monitoring services. Here, I'm going to introduce the Azure Monitor, Azure Service Health, and the Azure Advisor. First, I will give you an overview of system monitoring. The system monitoring is the process of monitoring a system to ensure that it is working properly. The system monitoring includes the infrastructure monitoring, such as the servers, networks, and operation systems, and the service monitoring, such as software, DNS, and load balancers. It also provides a trail of the who did what and when. You can take appropriate action when the problem occurs. Furthermore, it's also necessary to take a history of changes on the resource side, such as whether the resources in the operation are compliant with the appropriate rules. And this is an overview of the Azure Monitor. With Azure Monitor, you can monitor your resources by collecting the logs and metrics from the Azure environment, on-premises, or another cloud platform such as AWS and Google Cloud. The collected data can be transformed for the insight, visualization, analysis, alerts, and can also be integrated with other services for the actions. Azure Monitor is activated as soon as an Azure resource is created and collect data. Not only collect data, but you can configure additional settings or install agent to on-premise server. I will introduce the logs and metrics that make up the Azure Monitor. The logs are records of operation and changes that are collected from the system. In Azure Monitor, there are two types of logs, activity logs and event logs. Activity logs are logs about the operation performed by administrators. They are used for auditing and are crucial for understanding the what, who, and when for any right operation. Event logs are information about the application, security, and system. Typically, it means a Windows event. Logs are stored 90 days by default or stored on the storage account if you want to store more than 90 days. Metrics refer to the numerical values that represents the health and the performance of your system. These can include the performances indicator like CPU usage, network traffic, and memory usage. By installing the agent, you can collect various data. An alert is a notification triggered by a specific condition on your services. It has several components. The scope defines what resources the alert condition is evaluated against. Action group is a collection of actions to execute when the alert is triggered. This can include sending emails, SMS, calling a webhook. Condition is the specific criteria or thresholds that, when met, will trigger the alert. This includes the metrics or logs, such as high CPU usage. In Azure Monitor, the action can involve a variety of Azure services. The diagram shows the example of actions. Each service can be integrated with Azure Monitor to automate the response to alert. And next, Azure Log Analytics is a tool within the Azure Monitor that allows you to collect and analyze telemetry data from various cloud and on-premise resources. You can use queries called KQL, Cust Query Language, to analyze data. In Azure Log Analytics, you can refer various tables which contain data type specific to the particular category of data, such as event, metrics, and logs. You can use Azure Log Analytics by creating a Log Analytics workspace and connecting it to your data source. KQL have autocomplete feature, so if you are not familiar with KQL, you can easily create the queries. And this is an example of KQL. For a table called the storm event, the where clause filter for start time period, location, and counts and return. Here, I will introduce the detail of the KQL. The KQL is a rich query language used in Azure. It's mainly used in Azure Monitor, Data Explorer, and Log Analytics tools. And here are some of the typical syntax of KQL. As a basic syntax, you can create a condition statement with the where clause for the table name to perform the filtering, and you can use some function as well. Continuing with KQL sample, the KQL provides a wealth of functions necessary for analysis, allowing the statistical processing. In the AZ-104 exam, there have been questions about the KQL. While there are many functions in KQL, those that are examined in the exam are limited to the basic one. So you should be able to solve them if you have the reading comprehension. To give you a concrete image of the query, I have posted a query sample for the event, syslog, path, Azure Activity, and the Azure Metrics table. The first example is a query that aggregates the event at the error level by source in the events table, and displays a count in descending order. The record where event level name is error are filtered using the where clause. The second example is about the syslog. The syslog table aggregates the syslog messages related to the authentication error by computer. With the where clause, it filters with an AND condition where the facility signifies auth and the severity level signifies error. The event table stores Windows event logs, while the syslog table stores the Linux system logs. Continuing with the KQL example, we have a sample for the path, Azure Activity, and Azure Metrics. Again, the exam scope includes the KQL queries, and it also includes the RBAC, Policy, ARM template, which I will introduce later on this course. And since there are many queries, functions, and syntax, so it's not realistic to remember them all. If you have a time, I recommend you to refer to the official Azure documentation, but if you are limited on time, you should first get a sense of this difficulty and approach to solving through the practice question in this course. Next, I'm going to introduce Azure Service Health. Azure Service Health is a tool that visualizes whether there are any issues across the Azure services. You can receive alert notification by specifying the region and service, allowing you to be notified by the service health if an incident occurs in the region where you have to deploy your service. Moreover, you can check the service without signing in into Azure. It features functions such as addressing the service-related issues, the scheduled maintenance, health advisory, and security advice. In Service Health, the services without issue are indicated by a green icon, and yellow and red icons are displayed when there are any problems. Next, I'm going to introduce Azure Advisor. Azure Advisor is a service that provides recommendations for Azure resources according to the Azure's best practices. Azure has a set of design principles called the well-architected framework. A well-architected framework consists of 5 pillars: reliability, security, cost optimization, operational excellence, and performance efficiency. For example, Azure Advisor detects the unused resources and recommends that they be shut down. Azure Advisor scores compliance with a general recommendation. If you have specific policy in your environment, you will need to have your own separate policies. For Azure well-architected framework, Azure provides some support. Azure well-architected review provides the expert assessment and review of your Azure architecture. Azure Advisor automatically provides the recommendations based on the best practices. Azure also provides the official documentation, expert consulting from Microsoft partners, and the references architecture that summarize best practice for specific workloads. You can reference these through the Azure portal and official website. Next, I'm going to introduce security-related services. In this chapter, I'm going to introduce Microsoft Defender for Cloud, Microsoft Sentinel, Azure Key Vault, and Microsoft Entra ID. The first one is Microsoft Defender for Cloud. The Microsoft Defender for the Cloud is a service known as the CNAPP, which offers a unified security management across cloud and on-premises. It's employed to shield cloud resources from the cyber threats and the vulnerability. By activating Defender for Cloud, you can score and visualize the security postures of your resources based on the best practices. It provides the CSPM functions to prevent the cloud misconfigurations and CWPP features to centrally monitor and protect the multiple cloud services. For reference, Microsoft Defender is formerly known as the Azure Security Center and Azure Defender up to 2021. The services offered by Microsoft are prefixed with Microsoft. On the other hand, services offered by Azure are prefixed with Azure. This service has been elevated from Azure Defender to Microsoft Defender, which can manage not only Azure, but also non-Azure cloud services and on-premises services. I have explained the CNAPP, CSPM, and CWPP in the previous page. The CNAPP stands for Cloud Native Application Protection Platform, which integrates the security across the cloud and on-premises. The CSPM, or Cloud Security Posture Management, helps to prevent misconfiguration and ensure compliance. CWPP, or Cloud Workload Protection Platform, provides the centralized security management for multiple cloud services. The Defender for the Cloud offers both free and paid plans, with the paid plans providing more comprehensive features. The free version supports general security scores and recommendations. The paid plans allows integration and support with other cloud providers like AWS and Google Cloud, and includes the management of hybrid cloud. When linking with the other cloud services, you need their account information. For example, integrating the Defender with AWS requires adding the AWS account ID in the Azure portal and configure the scan setting. When you create an Azure account, the free version of the Defender is enabled by default for your subscription. You can upgrade for additional features through the Defender page. Next, I'm going to introduce the Microsoft Sentinel. The Microsoft Sentinel provides both SIEM, security information and event management, and SOAR, the security orchestration, automation, and response. This service was originally called Azure Sentinel, but is now known as a Microsoft Sentinel and supports resources beyond the Azure. It works in conjunction with Azure Monitor to collect logs and detect threats. And moreover, it can automatically respond to the detected threats. The SIEM is a system that collects data. It centralizes log data from various security devices such as Firewall, IDS, IPS, with detecting the abnormal behaviors. Through this process, it enables rapid responses to incidents. And SOAR is a system that automates and coordinates security tasks. It enables response to incidents detected by SIEM and minimizing the human intervention. The SIEM helps to understand what is happening by monitoring data, while SOAR uses the information to automate how to respond. Together, they work in tandem to enhance the efficiency of the detecting and responding to the security incident. Next, I'm going to explain what Azure Key Vault is. First, I'm going to introduce the encryption in the cloud. In cloud environments where sensitive data are stored online, encryption is an important measure for protecting the data from malware and ransomware. Encryption is the process of converting the digital data into a string of characters unreadable by unauthorized users. Since the cloud is online, it's necessary to encrypt both data at rest and data in transit. Encryption is the process of transforming plain text into an unreadable cipher. It uses the cryptographic keys and algorithms. The converted data can be reverted to its original form using a decryption key, a process known as the reversible encryptions. In contrast, irreversible encryption is known as the hashing. It generates the hash value that cannot be reversed. The hashing is commonly used in the digital signatures. There are symmetric encryption and asymmetric encryption method. Symmetric encryption is the method where the same key encrypts and decrypts the data, and asymmetric encryption which uses different keys for each process. The history of cryptography is very long, evolving with the advancement in computing. It's important to use the latest and the most secure cryptographic algorithm and use the secure key storage. The Azure offers a secure cryptographic method compliant with the standards like FIPS. Azure Key Vault is the key container service for storing keys and secrets. And you can not just store the keys, but also use a variety of features to secure your keys. Now I will show you the features of Azure Key Vault. Azure Key Vault is a redundant and highly available storage service with managed support for failover and data replication between regions. Azure Key Vault provides the key rotation functionality. This allows for more secure key storage. And you can do access control to the authenticated users with Entra ID and IAM. The premium version includes the HSM hardware security module, and which provides the infrastructure to generate the store the key. And this enables FIPS compliance, so you can use it for your compliance requirement. And you can set the soft delete between the 7 and 90 days. The default setting is 90 days. If you set a soft delete, when a user deletes a key, it is visually removed from the key vault, but the key remains actually and can be restored when needed. If delete protection is enabled, you cannot completely delete a key during the logical deletion period. You may use RBAC, role-based access control, to control access to Azure Key Vault. You can also have container role-based control, but at this time, Azure recommends the control by RBAC. RBAC control includes the creating and deleting a key container, setting access policies and tags as the key administrator, and includes encrypting and decryption as a data plane. And you can also do network level access control. This includes the setting up public access and private endpoint. Now I will show you the detail of the network service in later chapters. Next, I will introduce to the Microsoft Entra ID. The Microsoft Entra is the most important of authentication service of Microsoft. Firstly, I'm going to introduce authentication and authorization, which are two essential security processes. Authentication is the act of confirming identity, who you are, often done through the things like knowledge factor, the possession factor, and the inherence factor. And the authorization occurs after authentication and is a process of giving permission to access resources. So I will introduce the Microsoft Entra ID. The Entra ID is a cloud-based IAM service that is primarily used to access external resources. The Entra ID supports both external and internal resources, such as Microsoft 365, Azure, and other SaaS applications. It is the authentication infrastructure for Microsoft 365 and Azure, so when you create an account, an Entra ID tenant is created along with it. And this is an image of a single sign-on. The first, a trust relationship between the cloud service and Entra ID is established. The client makes a sign-in request to Entra ID, and after Entra ID authenticates the client, it responds with a temporary credential called a token. The client can then use the token to access cloud services. The Microsoft Entra is a suite of services released in the 2022. The Microsoft Entra is a suite of products that integrates identity and access management features. In 2023, Azure Active Directory was renamed to Microsoft Entra ID. In addition to Microsoft Entra ID, the Microsoft Entra includes the Entra Permission Management, Entra Verified ID, and so on. According to the Microsoft official information, though the name has changed, the basic product line remains the same, and you can continue to use the service without the need for additional configuration. These are the elements that makes up Entra ID: tenant, user, guest user, and group. When you create an account in Azure, it is automatically associated with the tenant in Entra ID. By default, only one tenant is created, and you can add tenant after that. The tenant will also contain the access control information for users, groups, and the tenant. You can add the users from outside your organizations as well as within Azure organizations. And these users are called the guest users, and you can invite them from the outside using the features called the B2B collaborations. A user has an ID, password, and other elements such as group membership, role, sign-in availability, job, and location. For example, if you restrict the user location to region in Japan, you can block access from outside Japan. And you can also create the multiple user in the batch by uploading the CSV. And next, a group is a collection of users, and they are useful for centralizing settings such as the licensing and permission for multiple users. There are two types of groups, the security and the Microsoft 365. The security is intended for common access, license assignment, and device management. And the Microsoft 365 is intended for the collaborative operation of Microsoft Office 365 products. In addition, there are two ways to manage membership in a group: assigned and dynamic. Assigned manually adds and removes members, and the dynamic automatically manages the members based on the rules. If you want to manage users dynamically, you can use a query to make a rule. And this function is called the dynamic membership rule. For example, a user whose department name equals HR can be automatically added to the group called HR. And with this, you can eliminate the need for manual administrations. At this time, dynamic membership is only available in paid plans. Roles in Entra ID are used to assign access rights and resource privilege to users and groups. And here is a sample of the role Entra ID provides. The Global Administrator role is the highest level of privilege that allows access to all administrative tasks within the tenant. In other words, Global Administrator can assign any administrator roles, manage users, reset password, and manage domains. The Azure recommends the role of the least privilege, so you should refrain from the unnecessarily applying the role with the string privilege such as Global Administrator. Azure's RBAC and Entra ID's roles are different concepts, so you should be careful not to confuse them. And I will explain the RBAC in the later chapter. The Microsoft Entra ID offers a range of features such as application management, authentication management, the Microsoft ID platform, and B2B and B2C collaboration, the conditional access, and device management. In the following pages, I'm going to explain the detail of the features. The Entra ID offers the authentication methods such as all-auth, OpenID Connect, and Samuel. The all-auth is an authentication framework that allows the application to get limited access to user account. In Entra ID, all-auth is used to provide the security tokens to authenticate identity. The OpenID Connect builds on the all-auth, adding the authentication layer that supplies the information about the user through the tokens. It enables the application to verify user identity. And Samuel is an open standard using the XML for exchanging the auth data between identity and the service provider. It facilitates the single sign-on for applications. Entra ID uses the Samuel protocol to offer single sign-on and multi-factor authentications. And this is an image of the all-auth flow. You first register your application in Azure Portal and getting application and tenant IDs. The users from the external application sign in via the application, and redirecting the OAuth endpoint with application ID, redirect the URL, and the response type included. And users enter credential on the login page. The application requests an auth code, and Entra ID issues a token, and then the application uses the token to access Microsoft Service APIs. The Entra ID provides several authentication methods, and you can combine them. For example, when you log into Azure with your ID and password, there is a risk of impersonation if leaked. To mitigate this, you can set access restriction for specific users, location, devices, and services within Azure. And you can also enforce the strong password requirements. If you forget your password or if you need additional verification, you can use SMS or your smartphone to enforce multi-factor authentication. And this verifies the identity more reliably. Besides the possession information, security questions can also be added for extra safety. In other words, authenticate not only with what you have, but also what you know. The more credentials you have, the more secure it is. But on the other hand, it is a cumbersome authentication process every time. The convenience and security are trade-off. Conditional access is a tool that protects your system based on the conditions. It includes some functions. Risk-based access control is based on the risk level of sign-in attempt. If the risk is high, it can enforce the additional security measures or block access altogether. Location-based access policies is based on where a sign-in attempt is made from. For example, access might be allowed from your corporate network, but restricted from unknown networks. A device compliance-based access is based on whether a device complies with your organization security policy. And you can set up application-specific access restriction and time-based access policy. And these conditional access policy can work together. And next, I will introduce device management. You can use the company device such as laptop, tablet, and the mobile devices, as well as bring your own device, BYOD. By registering these devices with Entra ID, you can securely manage them. You can configure to prohibit access from devices that are not registered with your Entra ID. With Entra ID's device registration, you can control access to your organization so that only registered devices are allowed in. This includes the ability for users to register BYOD. Entra ID is used to link users to their devices. Conditional access is a feature that controls access based on the status of security patches and whether encryption is enabled. Devices that do not comply with the policy can be set to be denied access. In mobile device management, MDM integrates with Microsoft Intune and provides device configuration, security policy enforcement, and remote control capabilities. And mobile application management, MAM, implements the data protection policies at the application level. There are three device access methods: Entra joined, Entra registered, and hybrid Entra joined. The Entra joins refers to the state where your device is directly joined to Entra ID. And this is typically used for devices that don't use on-premises ADDS or are meant for remote workers, and it mainly applies to the Windows devices. The Entra registered refers to a state where your BYOD is registered with Entra ID. It's commonly used with the personal Windows, iOS, and Android devices. And hybrid Entra joined means your device is joined to both on-premise and Entra ID. Next is how we're going to connect Entra ID with on-premise environment. Entra ID Connect is a tool that connects your on-premises directly with Entra ID. And this allows for a common identity for users and provides the seamless sign-in experience across the cloud and on-premise environment. It enables capabilities like password hash synchronization, pass-through authentication, and federation integration. The Active Directory Domain Service, ADDS, is a traditional Windows Server Active Directory, and you can extend your on-premise Active Directory into the Azure cloud. In the following page, I'm going to introduce the relationship ADDS with Entra ID. As I have explained, when you create an account in Azure, an organization called the tenant is created. Within the tenant, the subscription and the resource group are created. And you can also create the multiple tenants. In ADDS, an organization is called the forest. Within the forest, the domains are configured. The domains have parent-child relationships, creating a trust relationship between each domain. A domain with a parent-child relationship is called a domain tree. Each domain has a domain name, and the child domain inherits the DNS namespace from its parent domain. When a domain is added, it's copied over the network from the domain database by installing a domain controller running the Windows server. And next is the synchronization of user information from Entra ID to ADDS. When users are created in Entra ID and change their password, they are synchronized to the domain service, and this generates the password hash required for Serverless and NTLM authentications. The synchronization is one way. There is no reverse synchronization from ADDS to Entra ID. You may filter and synchronize only certain groups or users. With Entra Connect, you can also synchronize from ADDS to Entra ID. The target of synchronization includes the user account, the group membership, and hash value required for the credential. In addition, by enabling the write-back feature, you can synchronize the detail of settings such as password changes. When mapping users in the Entra ID and the ADDS, identity is checked based on the user name. If UPN or user principal names are not recognized, you can synchronize by defining a suffix with ID fix. With ID fix, you can check the synchronization status on an account-by-account basis to see the cause of the error. To ensure synchronization is working properly, you need to monitor the authentication infrastructure in your on-premise environment. With Microsoft Entra Connect Health, you can monitor your on-premise authentication infrastructure. By installing the agent on the server in your on-premise environment, you can build alert, performance, and usage in the Entra Connect Health portal. And this feature is currently available only in the premium editions. And finally, I'd like to introduce the editions of Entra ID. The Entra ID offers free the premium P1, P2, and ID governance editions. And we can see the features each offer in this table. For example, the multi-factor authentication and the conditional access are covered by the premium editions. The price and the feature may be updated in the future, so please check the latest documentation before actually using them. For your reference, I'm going into the defense in depth. The defense in depth in Azure is a security concept that uses a series of layer defenses to protect the data and information. The layer includes the data, application, compute, network, perimeter, identity and access management, and physical security. The Microsoft is responsible for the security of the cloud, such as physical layer, while the customer is responsible for the security in the cloud. Next one is compliance and governance. Here I'm going to introduce Azure Policy, Blueprints, role-based access control, lock and tag. And first off is Azure Policy. Azure Policy enforces different rules and effects over your resources. So those resources stay compliant with your corporate standard and the service level agreement. For example, you can have the policy that ensure all virtual machines have a certain tags, or that only certain types of virtual machine can be provisioned. Azure Policy can be defined by JSON format. A policy definition expresses what to evaluate and what action to take. For example, it can enforce the rules like all resources must have the specific tags. An initiative is the collection of policy definitions that are tailored towards achieving a broader compliance goal. The scope of a policy or initiative can be a subscription, resources group, or individual resource. And this determines where the policy or initiative is implemented and enforced. Azure provides hundreds of built-in policies. With these built-in policies, you will be compliant with most compliance. You can also customize your policy. Since the policies are written in JSON, you can customize them in detail. And this is an example of a custom policy defined in JSON. The policy contains the properties such as display name, policy type, parameters, as well as policy rules that indicates the condition and the effect of the policy. And this sample policy prohibits the deployment of resources outside of the specific region. And you can deploy this policy via the Azure portal, CLI, or PowerShell, and apply it by specifying the scope. From this page, I'm going to introduce some tips of the policy, and these tips may appear on the exam, so please check this out. If you create a new deny policy and assign to the existing resource, it does not delete the resource. Instead, the resource is marked as a non-compliant. Deny creation policies are typically used to prevent the creation of new resources that do not comply with the policy standard. Existing resources will be evaluated, but not deleted. Azure RBAC assigns roles to users and groups to manage who has what permission within Azure. Azure Policy, on the other hand, is applied to resources to ensure compliance with the organization standard and enforce the rules on resource property during the creation and update operations. And when resources is moved into a resource group to which an Azure policy is applied, the policy is applied to the resource. For example, if you move a resource from RG1 to RG2, it will apply to the policy of RG2 to the resource. The Azure policy enforces rules on resources when you create and update it. So again, please keep in mind these tips as they may appear on the exam test. Next, I'm going to introduce Azure Blueprints. Azure Blueprints was announced that it's depreciated in 2026, so it's only for reference. With Azure Blueprints, you can define a set of resources that comply with your organization requirement and compliance standard. A blueprint can include the roles, policies, resource deployment using the ARM template. With blueprints, you can centrally manage the multiple policy and RBAC, and also track and audit after deployment. You can create a custom blueprint from scratch or select a predefined blueprint samples. Predefined blueprint includes the compliance standard and the technical regulations such as ISO or CAF. The blueprints include the compliance framework such as CSS star, GDPR, ISO and IEC, and NIST CSF. While these regulations are not directly tested in the exam, but it would be practically beneficial to be familiar with them. It was announced that Azure Blueprint becomes depreciated in 2026. You will be expected to use the deployment stacks, the successor. And this is an infrastructure as a code service that deploys resources using the BICEP or ARM template. The next one is Azure RBAC. Azure RBAC, or Role-Based Access Control, is a system that provides the fine-grained access management to the resources. You can define who has access to the resources, what they can do with those resources, and what area they have access to. Azure role can be assigned at different scopes, from a management group down to a single resource. And this ensures that the user has only the permission they need to perform their jobs. The entity to which the role is assigned is called the security principal. The security principal is the entity to whom identification and access rights are granted. Security principals include the users, groups, service principal, and managed identities. The service principals are principals intended for unattended operation at the service level. For example, it can be attached to the resources to automatically perform action from one resource to another. A managed ID is an identity assigned to the Azure resource. There are two types of the managed IDs. The system-assigned managed ID is automatically assigned by the system. A system-assigned ID is automatically deleted when the resource is deleted. The user-assigned ID is an identity that is independent of the resource and can be shared by multiple resources. The Azure provides the two types of role, the built-in roles and the custom roles. The built-in roles are roles that are predefined by Azure. Like built-in policy, there are many types of built-in roles, and you can satisfy the most use cases within the built-in roles. You can also create the custom roles. You can define the roles in JSON. You can edit the IAM roles from the subscription settings screen. The IAM stands for Identity and Access Management. While AWS and Google Cloud offer IAM as an independent service, Azure offers it as a service built in Entra ID. The roles can be described in the JSON format. You can verify the JSON description by selecting the built-in roles. And here is a sample role defined in JSON. From the top, you can set the role's name identifier is custom to indicate that it is a custom role, and the role descriptions. The important parts of the roles are action and assignable scope. And you can define what actions are assigned to what scopes. For example, in this example, the action to start and read virtual machine are assigned to the subscription. And it is also possible to include operations you want to exclude in the not actions. In assignable scopes, describe what this role applies to. In this example, it's assigned to subscription, so subscription ID is described. The JSON format is outside the scope AZ-900 exam. However, since this is practical, I recommend you to get familiar with how to write in JSON. The roles provided by Azure include the owner, contributor, and leader. The owner has all permissions. That is, owner is authorized to perform all actions. The asterisk means that owner has all permissions. The contributor can perform the action other than security-related settings. The contributor cannot grant the privilege to other users. And the leaders have so-called read-only privileges. The leaders can view the resource but cannot make changes. When multiple roles are assigned within the same account, the union set or condition applies. For example, roles A can perform the operation other than deleting virtual machine, and role B can delete virtual machine. In this case, user assigned both role A and B delete virtual machine. And here I will introduce the differences between Azure roles and Entra ID's roles. Azure's roles and Entra ID's roles are different concepts and are independent of each other. The purpose of Azure role is to control access to Azure resources through ARM. Azure's role covers administrative groups, subscription, resource group, and resources. On the other hand, the roles in Entra ID manage permissions regarding the tenant, users, and devices. To manage resources, you need to grant both roles. The global administrator in Entra ID can elevate their own permission to User Access Administrator of Azure. And next, I'm going to introduce lock and tag. In Azure, a lock is a setting you can apply to the resource or resource group to prevent the modification or deletions. They can be applied to the subscription, resource groups, or resources directory. There are two types of lock: read-only, which allow viewing and listing but preventing changes, and delete, which prevents the deletions. And this helps to safeguard critical resources from the accidental changes or removals. The owner can remove a lock from the resources. And with the read-only lock, you can perform read operation but cannot modify or delete. With the delete lock, you can read and modify, but you cannot delete. In order to prevent the accidental deletion, you should set a delete lock and furthermore limit the number of users who can remove the delete lock. An owner has the permission to manage all aspects of the resources, including adding or removing locks. A user access administrator doesn't have the ability to remove a lock directly, but can assign roles to other users, which may include the permissions that allow those users to manage locks. Also, when creating the custom roles, it's important that only certain users be granted the ability to remove delete lock. And you can set the locks from the resource group or resource settings screen in Azure Portal. Add a lock and specify the name and the type of lock. And next I'm going to introduce the tags. The tags are key value pair that you can assign to resources, resource group, and subscriptions. They are useful for organizing the resources and managing them at scale, for instance by environment, department, project, or any other category that suits the organization's needs. The tags can be used for reporting, cost allocation, or automated operations like starting or stopping the service based on the specific tag. And they provide additional metadata to quickly identify the resources for various purposes. You can manage your tags in each resource's configuration screen. You can also search for tags in Azure Portal to see a list of the tags you have configured. And typical use case of tag includes a cost analysis. You can filter cost based on the tags on cost analysis page. For example, you can add the name of the department or environment to a tag to analyze how much a particular department or environment is spending cost. If you strictly manage the tagging with your organizations, you can create a policy that enforces tagging. For example, you create a tag called a department to represent the department name and deny the creation of resources if they don't have the department tag. And this type of policy helps prevent the missing tags. And next I'm going to introduce compute services. AZ-104 exam mainly focusing on the monitoring, security, compliance, and governance, as I previously discussed. On the other hand, it doesn't delve into the detail of the individual Azure resources. Therefore, from this chapter, I'd like to introduce the basic aspect of each resources. In this chapter, I'm going to introduce the virtual machine, serverless services, and the container. First, I'm going to explain virtual machines. Azure Virtual Machine, or VMs, are on-demand, scalable computing resources. They are equivalents of the physical computer, providing the flexibility of virtualizations. You don't have to buy and maintain the physical hardware that runs it. The VMs can be used for a wide range of applications, from development and testing to running large-scale applications and databases. And you have the option to choose the size of VM, the operating system, and the region where it's hosted. Azure provides the various VM types optimized for different workloads, like compute optimized, memory optimized, or storage optimized VMs. Azure's data centers are designed for high availability and redundancy. Inside the data center, server racks are carefully managed. There are multiple components such as power supply unit and network switches. And this ensures that if one component fails, there are backups in place to keep service online. Availability is further enhanced throughout the redundant power sources, cooling systems, and network connectivity. It usually takes only a few minutes to launch the virtual machine, and this time depends on the machine spec. Since the virtual machines are infrastructure as a service, the layer above the physical layer needs to be configured by yourself. The items you can configure include the machine specs, parameters, region, availability option, and so on. The image on your right is a virtual machine creation page. You can create it by Azure Portal or CLI. And this is far easier than procuring the physical server on-premise. And you choose CPU, memory, temporary storage, disks according to the characteristic of your workload. And I will introduce each element on the following pages. First, I will introduce the VM disks. And you can use VM disks without creating a storage account, and this is called a managed disk. A disk with creating a storage account is called an unmanaged disk. Now I'm going to introduce storage account again in the storage chapters. The virtual machine disks are external storage area that are attached to the server. The disk type can be changed or removed even after the VM has been started. At this time, there are the type of disks listed in the table here. From the top, we have standard HDD and SSD, the Premium SSD, Premium SSD version 2, and Ultra Disk. It's not necessary to remember the numbers shown here, but the lower you go, the higher the specs and the higher the price. In Azure Virtual Machine, disks play a specific role such as OS disk, temporary disk, and data disk. For OS and the data disk, you can choose the standard and the premium type. OS disk is a virtual hard drive where OS is installed. It includes a boot volume. OS disk is created in the Azure storage. In the Windows virtual machine, it is configured as C drive. A temporary disk is used for short-term storage. The data in temporary disk will be lost when you stop a VM. In the Windows virtual machine, it is configured as D drive. The data disk persistent data storage and resilient to VM reboots. OS disks and the temporary disk come with the virtual machine by default, but the data disks are attached additionally. And next is an OS image is a template that defines the specs of an operating system. You can get these images from the Azure Marketplace, those published by the third-party vendors. And you can also customize these images, which is known as a custom image. As of now, the option available includes the various versions of the Windows Server 2012 and later, as well as a range of Linux distributions such as Ubuntu, Oracle, Linux, Red Hat Enterprise Linux, and more. Azure's virtual machine comes in the range of sizes and performance level, identified by the series such as A, B, D, E, F, and so on. Each series is optimized for different workloads. For example, the series beginning with the A are entry level suitable for development and testing. And from a practical standpoint, you can choose the best specs for your use case. To connect to Azure VMs, you have the several options depending on the operating system. Remote Desktop Protocol, or RDP, is used for Windows-based VMs. RDP is commonly used to connect the virtual machine to graphical interface over the Internet or VPN. The Secure Shell, or SSH, is used for Linux-based VMs. SSH is the standard way to establish a secure command line connection for managing the machine remotely. And Azure Bastion provides the secure and seamless RDP and SSH connectivity to a virtual machine directly in the Azure portal over SSL. And this service does not require public IP address or VPN connections, and offering a more secure and managed access method. And next is the Azure Dedicated Host. Azure's Dedicated Host is a service that provides the physical servers. This is so-called private cloud service, which is hosted in the Azure and dedicated to your organizations. The dedicated host gives you more control over the server's infrastructure and helps with the compliance requirements that might not allow sharing resources. To create a dedicated host, first create a host group, which is a collection of hosts with a similar hardware located in the same Azure region, and then create the host within the host group. Lastly, the cost components of the virtual machine include the VM itself, disk storage, and networking. The price for the VM itself is based on the size and the type of VM you select. It's charged with the per minute of usage. You pay for the storage needed for the VM's OS disk, any additional data disks, and snapshot. As for network, outbound data transfer includes charges, but inbound is generally free. The data transfer within the same region is typically free, but crossing the region or outbound to the Internet is charged based on the volume of data transferred. Additionally, Azure offers reserved instances, which provide a discount if you commit to 1 or 3 years of service for VM. And this can result in the significant saving compared to the pay-as-you-go pricing. The specific discount rates vary based on the instance type and the region. The workload of VM is not always constant. Azure VMSS, or Virtual Machine Scale Set, is a service that lets you deploy and manage a set of auto-scaling VMs. You define the VM instance, and Azure can automatically increase or decrease the number of VMs in response to the demand or defined schedule. And this ensures your application remains responsive when the demand changes. The scaling can be manual or automatic based on the metrics like CPU load, memory usage, or network traffic, or on a schedule to handle the predictable load changes. You can configure the detailed behavior regarding the scaling. For example, you can configure the number of initial instances, scaling policy, scale-in policy, and so on. The initial instances are in the range of 0 to 1,000. The minimum instance can be set to 0, in which case the virtual machine charges 0 when it is not accessed at all. And as for the scaling policy, you can set the specified threshold, the maximum and the minimum number of instances, and the number of instances to be added. For example, you can set the instance will be added when CPU usage exceeds a certain usage. And the scale-in policy is the order in which VM are removed. For example, you can set to remove the oldest started VM first. In Azure VMSS, you can update VMs using a different strategy, manually, automatically, and rolling. And you can manually trigger an update to the scale set. And the automatic update is the update VM randomly. However, this approach could update all VMs, resulting in the out-of-service conditions. And the rolling updates are gradually applied to the VMs in the scale set in small batches. And this method helps availability by ensuring that only a portion of the VMs is under maintenance at any given time. It can also use the health probes to ensure that updated instances are running correctly before continuing with the process. And here I will explain the behavior of automatic scaling when multiple rules are applied. When multiple rules exist, the OR condition of multiple rules is applied for scale out, and the AND condition of multiple rules is applied for scale in. For example, if a scale out rule has a condition of 50% or more CPU, and 50% or more memory utilization, the scaling out will be performed if either condition A or B is exceeded. In other words, the OR condition is applied. On the other hand, if the scale-in rule is set to 50% or less CPU and 50% or less memory utilization, scale-in will be performed if the threshold for both condition A and B are exceeded. In other words, the AND condition is applied. And next I'm going to introduce serverless services. A serverless service enables developers to build the application without worrying about the underlying infrastructure. Azure manages the servers, scaling, and performance tuning. Azure App Service, Azure Functions, Azure Logic Apps, and Azure Event Grids are serverless services given by Azure. An app service often appears on the exam, and I will explain in the following pages. Azure App Service is a free managed platform for building, deploying, and scaling web applications. It supports multiple languages and frameworks such as .NET, Java, Node.js, PHP, or Python. And service includes the custom domains, SSL certificate, auto-scaling, and high availability. And it simplifies the management of your application with integrated service. To use App Service, you need to create the App Service plan. You choose the specs of the plan based on your workload. And you can deploy multiple app services on an app service plan. In addition, you can use the different frameworks. And this compares the differences between the app service and the virtual machine according to the shared responsibility model of the cloud. The application layer is managed by the client for both app service and the virtual machine. And for the data layer, the client is responsible for the database connection setting for the app service, while the client is responsible for the all setting for the virtual machine. And for the app service, the OS layer management such as patching, maintenance, and security measures is handled by Azure. And for network configuration, the app service is basically configured by Azure. The client only needs to configure the custom domain and SSL certificate. And for virtual machine, the client configures the virtual network, firewall, and load balancer. And for app service, Azure has the full control over the management of the infrastructure below the instance. In virtual machine, the client configures VM provisioning and scaling. Azure provides the physical hardware, storage, and networking. The app service offers the plans as listed here. From left to the right, free, shared, basic, standard, premium, and isolated. In addition, the premium includes the version 1 and 2 and 3, and isolated includes the version 1 and 2. The farther to the right, the higher the specifications. In practice, the standard and the above are used for the production environment. The isolated is the environment for running web application on an independent computing environment. And you can also change your app service plan if you need to scale after production. The location where app service content is uploaded is called the deploy center. The deploy center can work with repository services such as GitHub and Bitbucket. You can configure continuous deployment by using a GitHub Actions. The deployment slot in App Service are live web app environment where you can deploy your applications. Each slot can have its own settings, and you can swap them without downtime, enabling staged development and testing in production-like environment before going live. And this feature facilitates the management of different application version and configuration, simplifying the deployment process and reducing the risks associated with the update and changes. And lastly, I'm going to introduce some tips for app service. You can choose OS for Windows and Linux. The name of app service must be globally unique because it's to be included in FQDN. By the way, the name of the storage account must be regionally unique. The app service plan and app service region must be the same. And you can use the backup at the standard and higher plans. And next I'm going to introduce containers. The container services provided in the cloud are sometimes referred to the container as a service. A container is a lightweight, standalone package of software that includes everything needed to run a piece of software, including the code, runtime, system tool, library, and settings. The container isolates the software from its environment and from other containers, ensuring it works uniformly despite differences, for example, between development and staging environment. In order to understand the container, an analogy is often made. If a physical server is a house, the virtualization technology is a rental apartment, and a container is a share house. In a share house, the facilities such as the kitchen and the bathroom are shared by multiple residents, and each resident has their own living space, which increases the cost efficiently. The containers are more efficient by using the layer below the container engine as a common area, and using the application execution environment as the independent unit. And these are the components of the container using the Docker as an example. The components of the container include the container image, the build environment, registry, and the execution environment. The systems that manage the container are collectively referred to as the ecosystems. The Azure provides the container registry service as well as the Kubernetes service, container instance, and app service as the service for container deployment and orchestration. The Azure provides the several services that support all containerized applications. The Azure Container Instance, or ACI, offers the simplest way to run a container without having to manage the servers. It is the platform as a service solution that allows you to upload your container and run them directly with auto-scaling. The Azure Kubernetes Service, or AKS, is a managed container orchestration service based on the open-source Kubernetes system, which automates the deployment, scaling, and operations on the application container across the cluster of hosts. And the Azure App Service, which is traditionally used for the PaaS, also supports running container. And you can easily deploy and run containerized web apps that scale with your business. And in addition, Azure Container Registry is a registry service for container image. Azure Container Instance, or ACI, is a PaaS service that runs Docker containers. It offers the simple environment, and you don't have to provision VMs. The ACI does not have orchestration features like Kubernetes engine, which makes it a convenient choice for quickly creating the environment. And here are the steps for the setting up an ACI. You can choose between the private or public environment and select the specs like a CPU and memory as well as specify the OS, either Windows or Linux. With ACI, you can select and run images from the Azure Container Registry and Docker Hub. To persist data, you can use Azure Files. And next is the Azure Kubernetes service, is a service that allows the running of the open source Kubernetes, which is developed by the Google. While ACI is used for its simplicity, AKS includes a detailed feature that you can fine-tune non-functional requirements such as load balancing and fault tolerance. And with AKS, you can specify preset configuration for clusters. For example, there are presets available tailored for different environments such as development, testing, or a temporary use case like batch processing. And you can also configure the specs for the primary node pool, including the node specs and the scaling method. While the Kubernetes allows the setting of detailed environment, it also has the aspect of complex configurations. The following page will provide an overview of Kubernetes. And here, let me explain the components of Kubernetes. But this is outside of the scope of the exam, but I've included it for your reference. And firstly, a cluster is a set of nodes for running containerized applications. It contains at least one master node, which manages the cluster, and multiple worker nodes, where the application actually runs. A kubectl is a command line tool with which you can interact with your Kubernetes cluster. You can deploy application, monitor, and manage the cluster resources. And you can use kubectl on the Cloud Shell and Azure CLI. A master node is a machine that controls the Kubernetes node and is the main point of contact for administrative tasks. It hosts the Kubernetes control plane, which includes a component like the API server, scheduler, database, and so on. The worker nodes are the machines that run your applications. They are managed by master node and host the pod, which are the component of the applications. In Azure Kubernetes services, worker nodes are instances that are actually Azure virtual machines. The manifests are YAML and JSON files that define the configure Kubernetes resources. And here, this is a sample manifest for deployment. This manifest deploys the 3 pods using the Nginx image. The master nodes deploy to the worker nodes following this manifest. A pod is the smallest deployable unit. A pod is a group of the one or more containers with shared storage, network, and specification for how to run the container. The pods encapsulate the application's logic, the runtime, and all the dependency. The AKS provide additional tooling and services to make cluster management easier and more integrated with Azure ecosystem. The Kubernetes provides various APIs to manage workloads. I'm going to introduce some sample of the API. The replica set ensures that the specified number of the pod replicas are always running. They are typically managed by deployment. The deployment provides the declarative updates to a replica set, making it easy to scale application and perform rolling update. They support rolling update by gradually replacing the old replica set with new ones. The stateful sets are used to manage the distributed systems such as the stateful application and the databases. For example, they guarantee ordered pod deployment and scaling. And these objects allows you to meet the needs of various applications. And lastly, let me introduce the network element. The cluster IP is the access service via internal IPs within the cluster, which is used for the services that are only accessible within the cluster. A node port opens a port on the node for the external communications and used for the services that require access from the outside the cluster. And the load balancer routes traffic directly from the internet to the services. And the ingress acts as the layer 7 load balancer. And the external name is the domain name used to access external domains. It maps services to DNS names and resolves them as the CNAME records. And these are the main components that makes up the AKS. But Kubernetes is outside of AZ-104 exam. But if you are considering the career in development using the container in the future, it would be good to remember these components. Next, I'm going to introduce storage services. In this chapter, I'm going to introduce storage service, disaster recovery, and other storage-related services. First, I'm going to introduce the storage service offered by Azure. The object storage is used for the storing data as object, which also known as the blobs. Each object typically includes the data itself, metadata, and a unique identifier. The object storage systems allows you to retrieve an object via HTTPS, which is used for the web-based content. The object storage is highly scalable and used for many use cases, including the archiving, backup, storing large volume static data like image, audio, video file, and document. And in Azure, Azure Blob storage is offered. The block storage is an architecture that divides the data into blocks, each with a unique identifier. These blocks work like individual hard drives. The block storage is used in the storage area network, where data is stored in the volumes, also called blocks. It offers high performance and low latency, which is suitable for environments like databases, where rapid read and write operation are necessary. In Azure, Azure Disk Storage is provided. And file storage is the hierarchical storage used for organizing the data files. It is used for the regular file system, personal computers, and servers. And this is probably the storage type you are most familiar with, at least it's the most widely adopted consumer product. It can be shared among the multiple clients using the standard protocol such as NFS or SMB. And in Azure, you can use Azure File Storage. I'm going to introduce the storage accounts. In Azure, you need to create a storage account to use the storage services. You can create and access Azure Portal, CLI, as well as the endpoints. You can access via the endpoint as described here. And the name of storage account is included in the endpoint, so the storage account name must be unique in the region. The Azure offers 4 types of storage accounts depending on the data format. From the top, there are the blob, file, the table, and the queue. The table storage is the schemaless table, which is equivalent to the NoSQL database. And the queue storage is the messaging store for asynchronous connection between the application. I'm going to introduce details of blob and the file storage on the next chapter. At this time, the storage accounts have different pricing plans as listed here. And there are 2 major categories, standard and premium. And with the subcategory, the storage version 2, the blob storage and the file storage. And the storage version 1 is currently not available. The standard is the HDD-based storage, and which is suitable for storing the large amount of data at a low cost. The premium is SSD-based and is a performance-oriented storage type. Azure Storage provides different options for data redundancy, which ensures your data is replicated to the safeguard against the unexpected hardware failure and to meet the compliance requirement. I'm going to introduce each options. And firstly, locally redundant storage, or LRS, replicate your storage account 3 times within a single data center in the primary region. And this is the simplest redundancy option. The zone redundant storage, or ZRS, replicate your storage account synchronously across the 3 availability zones in the primary region. And each availability zone is a separate physical location with the independent power source. The GRS, or geo-redundant storage, your data is replicated in the secondary geographic location that is far away from the primary location. If the primary location becomes unavailable, the Azure storage fails over to the secondary location. However, with GRS, the data in the secondary location is not available for read and write access unless the Microsoft initiates the failover. With RAGRS, or Read Access Geo-Redundant Storage, and this takes the GRS a step further by providing the read-only access to the data in the secondary location, even if the primary location is still up and running. The RAGRS is designed for applications that require high availability and durability. It is more expensive than the GRS because it offers additional read access to the secondary region. The Geo-Zone Redundant Storage, or GZRS, combines the high availability provided by the redundancy across the availability zones with protection from the regional outage provided by geo-replication. The data in a GZRS storage account is copied across the 3 Azure availability zones in the primary region, and is also replicated to the secondary geographic region for protection from the regional disasters. Lastly, with Read Access Geo-Zone Redundant Storage, or RAGZRS, you can read the secondary region even if the primary location is still up and running. And this is the summary of redundancy option. Basically, the lower you go, the higher the availability. The availability of LRS and ZRS is guaranteed to be at least 99.999999%, 11 nines, and the availability of others are over 16 9. And I highly recommend you memorize these redundancy options as they appear frequently on the exam. The exam test frequently asks you to choose the correct redundancy option, focusing on whether or not the secondary region can be accessed during the normal time as well as in the event of failure. And again, with the lead access option, you can access to the secondary region even in the normal times. I'm going to introduce the Azure Blob Storage. The Azure Blob Storage is a service for storing the large amount of unstructured data, such as text or binary data, which accessible from anywhere in the world via the HTTP or HTTPS. The Blob storage has many use cases. The common use includes the serving images or documents directly to the browser, the storing the file for distributed access, the streaming the video and the audio, writing to the log file, storing the data for backup and restore, and disaster recovery, and archiving. The object storage does not have the hierarchical structure. On the other hand, by setting up the container, data can be managed like file storage, and you can access through the endpoint URL with container. The blob storage offers three types of blob: the block blob, append blobs, and the page blob. The block blob is used for storing the text and the binary data up to about the 4.75 TB, and they are made up of the blocks of data that can be managed individually. The append blob is optimized for append operation, making them easier for scenarios such as logging data from virtual machine. The append blobs are appended to block blobs. Append blobs do not have independent identifier, but inherits the identifier of block blob. The page blob is up to 8 TB in size and more efficient when ranges of bytes in a file are frequently updated, like as a disk or for the virtual machine. The blob storage has the concept of access tiers. The access tiers include the hot, cool, and archive. The frequently accessed data is stored in the hot layer, infrequently accessed data in the cool layer, and the rarely accessed data in the archive layer. The storage costs are higher for hot and lower for archive. On the other hand, with respect to retrieval operation, hot is cheaper and designed for quick data retrieval. The cool and archive have a minimum storage period. For example, if you delete the data in cool layer less than 30 days, but you will still be charged for 30 days of storage. And you can also use the lifecycle management. For example, the data that has not been accessed for 30 days can be automatically migrated from hot tier to cool tier. As a point of reference, S3 of AWS and the cloud storage of Google Cloud can be configured for lifecycle management as well. The AWS has a more fine-grained access tier than Azure. And next is the file storage options. The Azure files offer free managed file shares in the cloud that are accessible via the SMB or NFS protocols. The Azure file shares can be mounted concurrently by cloud or on-premises deployment of Windows, Linux, and Mac OS. The Azure file also has a storage tier, the Premium, Transaction, Optimized, Hot, and Cool. The Premium uses the SSD and has a high throughput performance. However, it is more expensive. The HDDs are used in the transaction optimize, hot, and cool. Basically, the higher you go, the higher the storage cost, while the transaction fee is lower. The Azure File Sync offers a smooth transition between the cloud and on-premises. It transforms Windows Server into a quick cache of your Azure file share, which enables you to maintain local access to your files. You first install the agent on servers and register them on Azure Portal, and next configure the sync group, cloud endpoint, and server endpoint. I will start here by introducing you to how to protect your storage. Azure Storage offers a variety of features to keep your data safe. The image is one I presented at the Key Management service. You can enable encryption for both data in transit and data at rest in storage service as well. The Azure provides several endpoints that can be used to improve the security. And it also provides fine-grained access control and soft delete. I will describe these in detail starting on the next page. You can control access by RBAC, role-based access control, which I have explained in the governance chapter. For example, if you want to grant a specific action for storage, you list the action with the Microsoft.storage. You can use several encryption methods for storage service. The Storage Service Encryption SSE is to automatically encrypt your data before persisting it to Azure Storage and decrypt it before retrieval. The client-side encryption allows you to encrypt data within your client application before uploading it to Azure Storage and decrypt the data when you download it. And these are the encryption methods for data at rest. In addition to this, Azure Storage provides the HTTPS encryption for data in transit by default. A Shared Access Signature SAS is a secure way to grant limited access to your storage account resources without exposing your account keys. A SAS provides delegated access to resources, in which you can specify what kind of resource and how long the SAS is valid and so on. And this is an example SAS URL. And here is a breaking down of the URL and what each parameter means. Resource, service version, start time, and expiry time. The signed resource and B stand for blob storage, and signed permission and R stand for read permission, and signature. In addition to these elements, you can configure IP address ranges and HTTPS protocol. The SAS is used for sharing the object to a specific number of users, but is usually used for the temporary file sharing purpose because of the risk of leaking the URL. I will explain other security features related to the storage account. The soft delete is a logical deletion feature which temporarily preserves the data that are deleted, allowing you to restore them if accidentally deleted. As for endpoint, you can use private endpoint, which provides secure connectivity over a private link. And you can also use the service endpoint, which is a secure and direct connection between your virtual network and the Azure service over the Azure's backbone network. The backbone's network is a Microsoft's own network. You can use the backbone network to transmit data without the influence of the Internet. For more information on the network service, I will introduce in the next chapters. Next, I'm going to introduce the services related to the disaster recovery. In general, disaster recovery is the strategy to continue and recover its technology infrastructure and operation after a disaster, which minimize the impact on the business operation and ensure business continuity. And two crucial metrics in disaster recovery planning are RPO and RTO. RPO, the recovery point object, is the maximum acceptable amount of data loss that an organization can tolerate in the event of failure. And RTO, the recovery time objective, is the maximum acceptable time for restoring the business operation and resuming the normal service level after a failure. The lower the RPO and RTO, the more robust the disaster recovery plan needs to be, as it requires a more frequent backup, faster recovery mechanism, and more redundant infrastructure. The disaster recovery scenarios are varied based on RPO and RTO. A backup and restore is the most basic form of disaster recovery. The data is regularly backed up and can be restored in the event of disaster. This option often has the longest RTO and RPO. The cold standby is the scenario where a secondary system is on standby and updated periodically. It's not running in real time, and it will take some time to bring online. RTO can be long, but costs are kept low because the resources are not used until needed. The warm standby is a more responsive setup than cold standby. It involves having a secondary system that more regularly updates and can be quickly activated. And hot standby is the most immediate and costly. It involves running a duplicate system in real time alongside the primary system. In the event of disaster, the secondary system takes over immediately with minimal downtime, achieving the shortest RTO and the lowest RPO. And next, I'm going to introduce backup service. Azure Backup is a cloud-based backup solution that provides a simple, secure way to back up your data and recover it from the Azure cloud. It supports a range of workloads, including the Azure Virtual Machine, SQL databases, Azure File Share, as well as the on-premise servers. And you can choose between LRS, GRS, and ZRS depending on your need for availability and redundancy. And you can configure the backup policy, including the frequency and retention, and monitoring the backup through the Azure portal. In the event of failure, you can perform a restore operation directly from the portal. And here I will introduce how to perform a backup of virtual machine. To perform a backup, first create the recovery service vault. And next configure the backup from the Azure portal. Set the backup policy, which includes backup duration, retention period, and so on. And specify the VMs to be backed up as well. Once the backup is configured, enable the backup. Backups of virtual machine are performed by saving snapshot. And next I'm going to explain the procedure for restoring the virtual machine. When a virtual machine crashes for some reason, go to the Recovery Service Vault in the Azure portal. Find and click on the vault that contains the backups of the VM you wish to restore. And first select a restoring point. Normally, the restore is performed from the latest backup file. You can choose whether to create a new VM from the restored data or replace the existing VMs. I'm going to explain some tips regarding the deletion of Azure Backup. You cannot delete the virtual machine unless the backup files are deleted first. To delete a virtual machine, you should stop the backup and then delete the backup data. And also check if the soft delete is enabled. The soft delete is a feature which protects against the accidental deletion of backups. If soft delete is enabled, it may take some time to delete the backup. Once the backup is successfully deleted, you can proceed to delete the virtual machine. By default, backups have a 14 days retention period for the soft delete. So after 14 days, the backup data is permanently deleted. In Azure, resources can have the dependency, which may prevent the deletion of the resource. And this is sometimes a topic in certification exam, so it's good to be aware of it. Next, Azure Site Recovery is a replication service for resources. It supports not only the replication of Azure resources, but also that of on-premises and on the other cloud service like AWS into Azure. With Azure Site Recovery, only the disks of the virtual machine are replicated. When a failover occurs, the virtual machine will run from the disk in the secondary region. Azure Backup and Azure Site Recovery are similar services. I'm going to introduce the differences between the two services. The difference between the Azure Backup and the Azure Site Recovery is that Azure Backup has a longer RTO. Azure Backup can only back up once a day, whereas Azure Site Recovery creates a recovery point automatically every 5 minutes. Azure Backup is typically used for backup, while Azure Site Recovery is used for the disaster recovery purpose. To configure Azure Site Recovery, you must first create a recovery service vault, and the process is the same as the setting up Azure Backup. Once the recovery service vault is created, you can configure site recovery. When enabling the replication, you specify the target region. For example, you might set US East as the primary region and US West as the secondary region for failover. You can also set the retention period for recovery point and the frequency of snapshot. And these snapshots capture transactional and temporary data to maintain the integrity of database services. Please keep in mind the Azure Site Recovery replicates only the disks. Therefore, you need to prepare resources such as virtual machine by yourself. When replication is enabled, the initial replication process begins. And depending on the amount of data, this replication may take some time. And after the initial replication is complete, Azure Site Recovery manages the continuous replication thereafter. In the event of failure in the primary region, a new virtual machine will be started in the secondary region, and the recovery will be executed from the disks. After a failover has been completed and the issues in the primary region have been resolved, you may want to resume operation in the primary region. In this case, you would enable a feature called reprotect. By reprotecting the virtual machine in the secondary region, you can replicate back to the primary region, and this process is generally called failback. Once reprotect is complete, you can carry out the failback from the secondary region to the primary region. Lastly, in this section, I'm going to introduce other storage-related services. And first, Azure Storage Explorer is a tool installed on the client operation system. It provides the user experience similar to Windows Explorer, enabling access to files stored in Azure. It supports Azure Storage Service and database services, not only browsing, editing, uploading, and downloading data. It also supports some features such as generating the SAS tokens. Additionally, by downloading the data to the client operation system, you can access data offline using the Storage Explorer. AZ-copy is a command line utility which is also installable on the client operating system similar to Storage Explorer. It enables various operations using the AZ-copy command. AZ-copy supports high-performance data transfer through parallel transfer and security features such as encrypted communications. Because AZ-copy is executed from the command line, it can be incorporated into the script of a batch process for automating process. The import and export service is a data transfer service utilizing the physical devices. And you can order data transfer jobs from the Azure portal and ship the data directly from the physical devices to the Microsoft data centers, enabling the transfer of the data from the on-premise environment to Azure. This service is often utilized for regions where the network transfers are challenging or for large-scale data transfers. It supports shipping from the on-premise to Microsoft data center, as well as from Microsoft data center to on-premises. Next, I'm going to introduce network service. First, to give you an idea, I'm going to introduce an overview of Azure's network services before delving into each service. Here is an image showing Azure's network services. The red-colored spaces are called the virtual network, or simply VNet. The VNet representing the address space within which resources are allocated IP addresses. When designing the VNet, you should ensure that you have a sufficient number of IP addresses available. Also, it's important to control the outbound and inbound traffic for VNets. The subnets are address space within the VNet. To connect to the Internet, you need a global IP address, or make local IP address translate to global IP address. The subnets connected to the Internet are called public subnets, while those communicating only within the VNets are called private subnet. And next, there are services such as Firewall to protect the network. The firewalls control the connection based on the IP address and block the packet with suspicious behavior. The firewall services offered by Azure include the security group, firewalls, DDoS protection, and so on. The CDN, Content Delivery Network, accelerates the access speed by caching the content between the clients and the content providers. The CDN leverages the Azure's globally deployed Endpoint to improve the access efficiency regardless where you are. You typically access the Azure space through the Internet. For more secure connections, you may use VPN or dedicated lines. The VPN stands for a Virtual Private Network, which the traffic goes through the virtual tunnel on the Internet. And the dedicated line can facilitate faster and much more secure access compared to the Internet. And lastly, load balancer evenly distributes the access across the multiple virtual machines, which ensures a balanced load distribution. And from the next page, I'm going to introduce each networking services. I'm going to introduce each networking service. First, I will introduce Virtual Network, VNet. Azure's Virtual Network, or VNet, is an isolated virtual network in Azure. The resources within the VNet can communicate with each other securely while being isolated from other networks. And you can also enable connectivity between virtual networks. You can define the address space for their virtual network using the CIDR notation. The address space defines a range of IP addresses that can be assigned to resources within the VNet. The VNet can be divided into one or more subnets, which allows users to segment their network. Each subnet can have its own set of IP address and security policies. Azure automatically provides a DHCP, Dynamic Host Configuration Protocol services within the subnet, allowing the resources deployed within the subnet to get the IP address dynamically. And you can configure several aspects in the VNet, such as subscription under which the VNet will be built, resource group, region, address space, subnet, DNS servers, and network security groups. It is important to choose a region close to your resources for optimal performance and compliance. Now I will explain DNS and the network security group later in this chapter. Resources on Azure need an IP address to communicate with other resources. When a resource, such as a virtual machine, is launched, a network interface is automatically created and the IP address is associated with it. In Azure, IP addresses can be classified based on their accessibility and assignment method. As for accessibility, Azure provides public and private IP addresses. A public IP address is a publicly accessible address. On the other hand, a private IP address is assigned to resources within the virtual network. These IP addresses are not accessible from the Internet and are used for internal communication within the virtual network or between interconnected virtual network using the VPN or ExpressRoute connections. And as for assignment method, Azure provides static and dynamic addresses. A static IP address is a fixed address which remains the same unless explicitly changed by user. A static IP address for routing purposes, such as web server or VPN gateways. A dynamic IP address is assigned dynamically by Azure from the pool of available addresses. Each time an Azure resource is started or restarted, it may receive a different IP address from the pool. Next, I will introduce routing. In Azure, the traffic between virtual networks, on-premise networks, and the Internet is controlled by a routing table. Azure automatically creates the system routes unless you explicitly define your routing. For example, this is the routing table of multiple resources within the multiple VNet. Resources are created within the CIDR range of virtual network, and routing between these resources is established to allow the traffic. These are Azure default system route, which includes the route traffic within the virtual network to other subnet in the same VNet, and between the peer VNet, the traffic to the VNet, and the traffic to the Azure services. And you can also add custom routes to modify these default routes. As mentioned, Azure's system routes are created by default. For example, the routing from the VM1 in subnet A to VM3 in subnet C is usually set up like this. However, you can customize your system route. For example, if you install a third-party monitoring tool on VM2 in subnet B and want to monitor traffic from the VM1 to VM3, you might use a user-defined route. When defining a route yourself, you need to explicitly add routes. Add the route in the route table and set the destination and the next hop. And you can set IP addresses and the service tag as a destination, and virtual network gateway, virtual network, internet, and the virtual appliance as a next hop. And once associated, the user-defined routes table overrides the default system route. In other words, if the same address prefix is contained in both the default system route and the user-defined route, the user-defined route will take priority. Next, I will introduce the firewalls. In this section, I will introduce the Network Security Group, Application Security Group, Azure Firewall, and DDoS protection. Azure Network Security Group, NSG, acts as the virtual firewall that allows or denies inbound and outbound traffic based on the user-defined rules. You can define the security rules based on the factors such as the source and the destination IP addresses, port, and the protocols. NSGs can be associated with subnet, network interfaces, or individual virtual machine within the Azure VNet. When an NSG is associated with a subnet or network interface, the defined security rules apply to all resources within that subnet or network interface. And you can define inbound and outbound security rules that specify which type of the traffic are allowed or denied based on the factors such as source, destination IP address, the ports, and the protocols. The security rules have the priority assigned to them, determining the order in which they are evaluated. The rules with the lowest priorities is evaluated first. If a matching rule is found, the further rule processing is stopped, and this allows the user to define the precedence of the rule effectively. NSG also supports stateful filtering, which means They automatically allow return traffic for outbound connection initiated by the resources within the VNet. Every NSG includes the default rules that allow outbound traffic from resources within the VNet and deny all inbound traffic by default. And you can modify these default rules and add custom rules to meet specific networking requirements. And next is ASGs. ASGs is a component of network security with which you can group virtual machines based on the application workload they belong to. Instead of defining network security rules based on the individual VMs, ASG enables use to apply rules entire application groups. And you can associate with the ASG with NSG rules, allowing you to define the security policies based on the application groups and enforce them at the network level. With ASGs, you can group multiple VMs within a subnet. For example, this is an architecture for three-tier structure, where the connection from the web servers to app server and database servers, where the traffic sent from the internet. In this example, the app server and DB server grouped with the ASGs. The security rules allow the connection from the internet to ASG1, then from ASG1 to ASG2, but a direct connection from the internet to ASG2 are not allowed. By using ASGs, you can simplify the complex network design into more straightforward ones. And next is Azure Firewalls. Azure Firewall is a centralized firewall solution for controlling and the monitoring traffic flow within the VNet and between VNet, as well as between VNet and the Internet. It is a stateful firewall that filters traffic based on the source and destination IP address, port, and protocols. Overall, Azure Firewall provides the comprehensive network security for virtual network with advanced features for traffic filtering, application-level control, threat detection, and centralized management. And this is a summary of differences between NSG and Azure Firewall. Both are essential components of network security, but they serve different purposes and offer distinct features. Azure Firewall is a centralized, stateful firewall service that provides a comprehensive protection and advanced feature for controlling and monitoring traffic between Azure VNet, Internet, and on-premise network. NSG, on the other hand, offer basic network-level security filtering for traffic within the VNet and between the subnet, but it doesn't have the application-level filtering and the scalability feature of Azure Firewall. And next one is Azure DDoS protections. And first, I'm going to explain what the DDoS attack is. A malicious attempt to disrupt the normal operation of an online service by overwhelming it with a flood of internet traffic. It is called a denial service attack, DOS attack. In a DDoS attack, a large number of compromised devices, which is called as a botnet, are coordinated to send a massive volume of requests to the target. Azure DDoS protection is designed to defend against DDoS attacks. It automatically monitors network traffic and identifies a potential DDoS attack in real time. When an attack is detected, it activates to mitigate the attack and prevent the service disruptions. DDoS protection offers two tiers, Basic and Standard. The Basic plan provides the automatic protection against the common DDoS attacks for all Azure resources at no additional cost. The Standard plan offers more advanced feature customization option and enhanced protection against a wider range of DDoS threats, but additional costs are necessary. And next I'm going to introduce the DNS service. A DNS stands for Domain Name System. It is the decentralized hierarchical naming systems for resources connected to the Internet or private network. A DNS translates the domain names, which are easy to remember, and human-readable names like www.google.co.jp into numerical IP addresses. To help you understand the DNS name resolution process, I will use a specific example. This image shows how DNS queries are resolved. A user enters the domain name www.example.com into the browser. The user's computer queries the DNS resolver to convert the domain name into an IP address. The DNS resolver first queries the DNS root name server and requests information about the .com top-level domain. The domain name consists of the several parts. In this example, .com is a top-level domain. When resolving the names, the queries are executed sequentially starting from the top-level domain like .com, .co.jp, .org, and so on. The root name server instructs the top-level domain name server, indicating the server responsible for managing the .com domain. The top-level domain name server further forwards the query to the Azure's name server, directing it to the server responsible for managing the example.com domain. And the name server returns the IP address 192.0.2.44 for the requested domain name www.example.com to the DNS resolver. The DNS resolver returns this IP address to the end user's computer, and the end user browser connects to the web server using this IP address. Azure DNS is a cloud-based DNS service by Azure. With Azure DNS, you can host and manage your DNS domains and records in Azure. Azure DNS provides a reliable and scalable DNS resolution for both public and private domains. Azure Public DNS is used for resolving domain names for internet-facing resources, while Azure Private DNS is used for internal name resolution within the VNet. Azure DNS gives a hierarchical structure. When you try to resolve the domain name, the DNS resolver will query the root name server to get the information about the top-level domain, for example, .com, .net, .org, and .info. And this hierarchical structure of name server, from the root to the top-level domain, are finally to the authoritative name server that allows for the efficient and scalable resolution of domain names on the Internet, including the domain hosted on the Azure DNS. Azure DNS enables the name resolution within the VNet through the use of the private DNS zone. When resolving the name within the single VNet, resources within the VNet can reference the addresses of other resources through the Azure DNS, which allows for communication between the resources. The private DNS zone have two types of associated virtual network: Resolver Virtual Network and Registration Virtual Networks. In Resolver Virtual Network, the administrator manually manages the record. In Registration Virtual Network, the record for resources connected to the virtual network are dynamically registered in the private DNS zone. Therefore, you don't have to manage the records themselves. You can enable auto-registration of the Registration Virtual Network in the Azure portal. Azure DNS can also perform the name resolution across multiple VNet in different regions. And this image shows a private DNS that operates between two VNet. When a request is sent from VM in VNet 1 to VNet 2, the DNS performs a query for the record and returns the corresponding IP address. And lastly, I'm going to introduce the price and the tips for the Azure DNS. Azure DNS operates on the pay-as-you-go model based on the number of DNS zones and DNS queries. The DNS servers are distributed globally, ensuring the high availability. Without DNS service, you cannot communicate anymore, so DNS typically offer high availability. Azure DNS offers 100% service level agreement. Azure DNS leverages the data center and the point of presence across the region worldwide. Azure DNS follows the geographical proximity rules to respond from the nearest location geographically. Next, I'm going to introduce CDN service. A content delivery network, CDN, is a distributed network of servers strategically located across the various regions. CDN caches static content. When a client requests a content, the origin server directly replies response. However, when a multiple client requests the same content, the origin server becomes overloaded. In this case, the CDN serves it from its cache instead of fetching it from the origin server each time. And this reduces the load on the origin server and improves overall performance. Azure CDN is a high-performance CDN service by Azure, deliver content with low latency and high availability. Azure CDN works by caching copies of the content and strategically distributes the edge locations, known as point of presence (POPs). The Microsoft has about 200 POPs across the world. In Azure CDN, you can use CDN services from Akamai, Verizon, as well as Microsoft one. The next one is Azure Front Door, another CDN service. Azure Front Door is a global, scalable, and secure CDN service. Compared to Azure CDN, Azure Front Door offers richer functionality. It acts as a global load balancer, distributing the incoming traffic across the multiple backend resources. It offers the various routing policy, including the path-based routing, URL-based routing, and weighted routing, to determine how to distribute traffic to backend resources. Azure Front Door can terminate SSL certificate at the edge, which means it handles the encryption of the traffic. It integrates with the Web Application Firewall, protecting your application from common web-based attacks. This table highlights the main distinction between Azure CDN and Azure Front Door. Azure Front Door provides a more comprehensive set of features compared to Azure CDN, making it a better choice for dynamic web applications that require advanced load balancing, routing, security, and global delivery. And Azure CDN is more simpler for static content delivery use cases. Next, I'm going to introduce peering. The peering refers to the establishing the direct network connection between two virtual networks or between Azure Net or on-premise network. The peered networks can communicate with each other securely and efficiently as if they are part of the same network. The peered connections are private and secure using Azure's backbone network. The VNet peering enables the communication between the resources in VNet located in the different region, subscription, and tenant. The peering across the different regions is called global VNet peering. When setting up the peering, there are several important considerations to keep in mind. The first one is address space overlap. Ensure that IP address ranges of the peered virtual network do not overlap. Overlapping address spaces can cause routing conflict. In Azure, peering relationships are not transitive by default. This means that if VNet 1 is peered with VNet 2 and VNet 2 is peered with VNet 3, the traffic cannot flow directly between VNet 1 and VNet 3 unless there is a direct peering relationship established between VNet 1 and VNet 3. And the issue is common not only Azure, but also in AWS and Google Cloud. And you can establish the peering in the Azure portal. Just choose the VNet that you want to peer with another VNet. And you can specify the peering settings such as the allowing forwarded traffic, enabling the gateway transit, and the configuring the traffic forwarded method. And next, I'm going to introduce VPN. The VPN stands for Virtual Private Network. It's a technology that allows users to establish a secure, encrypted connection between their device and the remote network over the Internet. And here are the key points about the VPN. The VPN creates the secure, encrypted tunnel between the user's device and the remote network. And the VPN enables the user to securely access resources hosted on the remote network as if they were directly connected to the network. The VPN can help to preserve the user privacy by masking the user's IP address, making it harder for third parties to track their online activities. The VPN uses various protocols to establish a secure connection, such as IPsec, L2TP, PP2TP, and OpenVPN. From next page, I will introduce the VPN service offered by Azure. And this is a summary between VPN and peering. The VPN are used to create a secure connection over the Internet, while peering is used to establish the direct connection between VNets or between Azure and on-premises. Each technology is used in the different scenario to meet a specific requirement. The VPN connection includes the site-to-site, the point-to-site, and VNet-to-VNet connections. Site-to-site connections are VPNs that connect an on-premise to VNet. It's commonly used for secure access from the company side to an Azure environment. Point-to-site connections connect individual clients to the Azure VNet. It's used to connect the client's computer at any location. And you can also establish a VNet to VNet VPN. A site-to-site and point-to-site connection use Internet, while VNet to VNet VPN use Azure's backbone network. However, in most cases, the peering connections are used unless there is a special reason. It is used when high throughput is not required or transitive routing is needed. The peering connections do not provide the transitive routing unless explicitly allowed, but VPN connections simplify the routing. The Azure offers two types of VPN gateways. The policy-based VPN are used for establishing the site-to-site VPN. The traffic is routed based on the policy defined in the VPN gateway. And the route-based VPN use dynamic routing protocols such as BGP to establish the connections. The route-based VPN are suitable for complex network topologies and offer more flexibility. You can find the latest information about the VPN gateways generation and SKUs in the official Azure documentation. And this documentation includes the SKUs, throughput, and so on. The generation includes a basic VPN gateway 1, 2, 3, and each with its own performance. For your reference, IPsec, IKE, OpenVPN, and SSTP are all VPN technology used to establish a secure and encrypted connection over the Internet. Each protocol has its own feature, and the choice of the protocol depends on the type of VPN. Site-to-site VPN typically use IPsec and IKE. The point-to-site VPN use the OpenVPN, SSTP, and IKE version 2. And VNet to VNet VPN use the IPsec and IKE. To establish the VPN connection, you need a VPN gateway, which is required for site-to-site connection and point-to-site connection, and connection between Azure resources. To create a VPN gateway, you first need a dedicated subnet called the Gateway Subnet. And this subnet is exclusively used for the VPN gateway. The VPN gateway itself is implemented as a virtual machine, with software-based VPN installed on it. The Gateway Subnet is a dedicated subnet for the VPN gateway and cannot contain other resources. Additionally, you cannot use an existing subnet as the Gateway Subnet. In Azure Portal, you can add a Gateway Subnet by navigating to the subnet setting of your virtual network. From here, select the Gateway Subnet and proceed to add it. When adding the Gateway Subnet, you will go through a process similar to creating a regular subnet. You will choose the address range, IP address type, and options such as a NAT gateway, network security group, and route table settings. And you can also create a virtual network gateway from the Azure portal. When creating the gateway, you specify the subscription, region, SKU, and generation. You can have up to 2 public IP addresses, each with up to a 3 availability zone configured. Furthermore, you can enable zone redundancy. When you create a VPN gateway, 2 instances are deployed internally, which act as the active standby. You can also choose ExpressRoute. ExpressRoute is Azure's dedicated line service, which I will explain in the next chapter. To access to Azure, you need to set up a VPN device on your local environment. From the Azure portal, you can configure the local network gateway. You configure the routing to on-premise VPN devices by setting up the IP address of the local network gateway. Additionally, you can use advanced configuration to enable connection to multiple on-premise VPN devices by configuring the BGP. Next, I'm going to introduce ExpressRoute. ExpressRoute provides a private, dedicated connection between on-premise and Azure's data centers. ExpressRoute connections do not traverse the public internet, ensuring that the data remains private and secure. Thus, ExpressRoute is much more expensive than VPN. It offers high bandwidth connectivity options ranging from the 50 Mbps to 100 Gbps, which transfer large volume of data. It also offers multiple connectivity options, including the layer 2 and 3. And this is a summary of a location type of ExpressRoute. ExpressRoute Local is for connecting the service within the same region. ExpressRoute Standard is for services within the same geopolitical region. For example, a service in the region in the US can access a service in another region in the US. ExpressRoute Premium offers global reach. There are 3 connection methods for ExpressRoute: point-to-point Ethernet connection, co-located at the cloud exchanges, and any-to-any networks. Point-to-point Ethernet connections involve the connecting directly from on-premise to the Microsoft environment via the dedicated line. It can provide either L2 or L3 connection layers. Co-located at the cloud exchange or L2 connection service allows the user to contract with the provider that brings a line to the connection point with Azure. You can then install equipment with the provider's premises. Any-to-any network or L3 connection service use wide area network from the provider that have already been brought to the connection point. And this is the cost-effective way and easier to implement than co-location. When you create an ExpressRoute, you can pair with Microsoft resources and Azure resources. With Azure peering, you can connect to Azure resources within the virtual network using private IP addresses. With Microsoft peering, you can connect to the services of the Microsoft. With Microsoft peering, you can only use the public IP addresses, so you will need to translate private IP address to public IP address on your side. You can create an ExpressRoute from the Azure portal. and this is a creation page for ExpressRoute circuit. When creating ExpressRoute, you will choose the port type, provider, peering location, bandwidth, SKU, and billing model. In this screenshot, AT&T is selected as the provider, and East US is chosen as the peering location. The bandwidth varies depending on the provider and the peering location. After creating ExpressRoute, a service key is issued. This service key is needed for the initial configuration with the provider. To use ExpressRoute, you will need to create a gateway, and the creation process is similar as how you create a VPN. You can achieve redundancy and cost savings by using both VPN and ExpressRoute. Typically, you will use ExpressRoute for primary connectivity and rely on site-to-site VPN as a backup. This ensures that even if one connection goes down, you can maintain connectivity. While ExpressRoute is generally very safe and reliable service, but past incident with AWS Direct Connect, which is a dedicated line service of AWS, highlights the importance of the redundancy. To control cost, consider using ExpressRoute for critical locations and VPN for others. Remember, whether using ExpressRoute or VPN, you will need a gateway. I have mentioned the BGP in the VPN and ExpressRoute chapters. Here, I'm going to briefly explain the BGP for your reference. BGP, or Broader Gateway Protocols, are routing protocols used to exchange routing information between the different autonomous systems on the Internet. The BGP protocol helps routers in one AS learn about the network in other AS and determine the best path to reach them. BGP is essential for the function of the Internet, as it enables the interconnection of different networks and facilitates the exchange of routing information globally. Next, I'm going to introduce one service. Virtual WAN, or Wide Area Network, is a large-scale inter-site service. With Virtual WAN, you can connect site-to-site VPN, point-to-site VPN, and ExpressRoute in a hub-and-spoke architecture. It consolidates the multiple connection service into a single operational interface. And each virtual hub can support up to 1,000 site connections, while the VPN gateway supports only 30 tunnels for site-to-site connections. Virtual WAN also enables a transitive connection, which simplifies the network configurations. Virtual WAN has two pricing plans, Basic and Standard. And with Basic plan, you can configure only site-to-site VPN connections, and Standard allows you to configure site-to-site VPN, point-to-site VPN, ExpressRoute, and transitive connection between VNet. While you can upgrade Basic to Standard, but downgrading is not possible. Next, I'm going to introduce Service Endpoint and the Private Endpoint. The Service Endpoint allows you to directly connect from your virtual network to Azure services. With Service Endpoint, traffic from your virtual network to Azure services doesn't go through the Internet, but through the Azure's private backbone network. And you can use the public IP address of your virtual network. Service endpoints are used, for example, when accessing the storage services from the virtual machine, where Internet access is not necessary. You can enable Service Endpoint by selecting the specific services from the Subnet settings screen. And once enabled, the Service Endpoint is added as the next hop in route information. You can also specify the Service Endpoint as the destination and the source when configuring the firewalls. And next is the private endpoint. A private endpoint serves as an endpoint for Azure Private Link. The private endpoints are similar to service endpoints. They also provide a direct connection from your VNet to Azure services. They bypass the internet and using the Azure backbone network. Unlike service endpoints, you can use the private IP address with a private endpoint. To create a private endpoint, you explicitly create it as a single endpoint rather than configuring it from the subnet. When creating a private endpoint, you need to specify the resource, virtual network, and DNS settings. And this creates a network interface card with an associated IP address. Additionally, you can access resources using a FQDN from DNS settings. And here is a summary of the differences between the service endpoint and the private endpoint. The both use the backbone network instead of the internet. The service endpoint uses public IP addresses, while private endpoint uses private IP address. The service endpoints are limited to access from within the same region, whereas the private endpoints allow private connection to other regions. Additionally, private endpoints support connections from various networks like the peering, ExpressRoute, and VPN. Next, I'm going to introduce Load Balancer. A load balancer is a networking service that distributes incoming traffic across the multiple servers. It prevents any single server from becoming overwhelmed and causing the downtime or performance issues. Its primary purpose is to enhance the availability and reliability by evenly distributing the workload. Azure offers two types of load balancer. On your left, Azure Load Balancer is a Layer 4 TCP and UDP load balancer service. It works at the network level and is easier for load balancing traffic for applications with a high throughput requirement. Azure Application Gateway is a Layer 7 HTTP-based load balancer. It can route traffic based on the URL path or host headed, perform SSL termination, and provide web application firewall functionality. From next page, I'm going to introduce each load balancer. Azure Load Balancer is a Layer 4 load balancer. It works internal and external of Azure VNet. In other words, it distributes the incoming traffic across the multiple virtual machines and the resources within the virtual network. Azure Load Balancer generates a hash value to uniquely identify the communication flow by combining the 5 elements: source IP address, source port, destination IP address, destination port, and protocol. And this 5-tuple hash value is used to perform load balancing by distributing the traffic in a round-robin-like fashion. In the context of the load balancing, round-robin means a method where the requests are distributed evenly across the server. This image shows the configuration of load balancer. Load balancer rules define the load balancing rules. inbound NAT rules and outbound rules. Load balancing rules define how incoming traffic is distributed across all the instances of the backend pool. Inbound NAT rules are methods used to forward traffic from the internet to the backend, and outbound rules define the method of network address translation from the backend pool to the internet directions. A front-end IP address is attached by the default and can be optionally added. The front IP address allows for the aggregation of public address into one address, which can be accessed from the outside as if it were a single server. It also saves consumption of public IP address. A public load balancer has a public IP address, so you don't have to provide the public IP address to each virtual machine in the backend pool. The public load balancer also has a private IP address, which is used to monitor the status of the backend pool. The backend pool refers to the group of virtual machines. And the health probes are the function that monitor virtual machine in the backend pool. The health probe prevents the connection to unhealthy virtual machine. And you can set session persistent in the load balancer rules. A session persistence ensures that requests from a specific client are directed to the same backend server. And this is achieved by routing based on the client IP address and the source port. And this is useful for applications that require stateful interaction, such as maintaining the shopping cart. When using session persistence, you have to be careful not to concentrate too much traffic on a particular VM. The health probe is a feature that monitors the virtual machine in the backend. The way of monitoring depends on the protocol. For TCS protocol, it's done by a three-way handshake. And in HTTP traffic, it checks the response record, for example, 200 for success and 400 and 500 for error. The health probe prevents the connection to unhealthy virtual machines. And this is a summary of Azure Load Balancer's SKU. Azure Load Balancer comes in two SKU, Standard and Basic. The Standard provides high performance and availability. It has an SLA of 99.99% and supports both IP-based and NIC-based backend. And you can have up to 1,000 instances in the backend pool. It supports availability zone, allowing for high availability configurations. A standard is a pet plan. The basic plan used for small-scale applications. It does not have a defined SLA, and the maximum number of the instances in the backend pool is lower at 300 compared to the standard. The basic is a free plan. Azure Application Gateway is a Layer 7 application-level load balancer. It routes traffic based on the additional attributes of HTTP requests such as URL paths and host headers. For example, on an e-commerce site, you can route requests to the server pools specialized in the product information or account management based on the URL path. Similarly, routing based on the host name is also possible. Now, I'm going to introduce some security features of Application Gateway. Application Gateway includes a built-in WAF that helps protect web applications from common threats such as SQL injection, cross-site scripting, and other vulnerabilities. It provides the centralized protection for web applications, and you can customize the rules and policy to meet a specific security requirement. The application gateway supports SSL termination, allowing it to handle encrypted traffic from the client and decrypt it before forwarding it to the backend server. And you can also enable SSL breach, which is the configuration where SSL encrypted traffic from the client is terminated at the load balancer and then re-encrypted before being sent to the backend server. And here I'm going to explain the components of Application Gateway. Application Gateway configuration is similar to that of the load balancer, so I will introduce a specific component. And the first one is a listener. A listener is configured to listen on a specific port and protocol. For example, you might have a listener configured to listen on the port 80 for HTTP traffic or port 443 for HTTPS traffic. The listeners are associated with the routing rules that define how incoming requests should be forwarded. And these rules typically include the criteria such as incoming URL path, host header, or request type. For HTTPS listener, SSL certificate can be configured to enable SSL termination. In HTTP settings, you can specify the protocol and port for the backend pool. You can specify encryption between the application gateway and the backend pool with a protocol such as HTTPS. For web applications that use cookies, you can use cookie-based affinity to maintain session information. And you can also configure the association with the custom probes to set up the detailed health probes. Now finally, I'm going to introduce Network Watcher. Network Watcher is a monitoring and diagnostic service. You can monitor, diagnose, and get insight into your network infrastructure. It provides several tools, and I'm going to explain each of them from next page. The topology provides a visualization of the network architecture. It shows the relationship and the connectivity between the various network resources. With topology, you can easily understand the layout of your network infrastructure. The Connection Monitor allows you to monitor connectivity between the virtual machine and the remote endpoint. It checks the connection at a regular interval and provides a real-time insight into network latency, packet loss, and the connectivity status. With Connection Monitor, you can identify and troubleshoot connectivity issues. Network diagnostic tools provide many kinds of network-related diagnostic troubleshooting capability. I'm going to introduce each feature. IP Flow Verify allows you to test network traffic between virtual networks. It verifies whether traffic allowed or denied based on the network security group rules and networking routing. NSG Diagnostic provides a detailed analytics of network traffic allowed or denied by NSGs. Next hop allows you to determine the next hop IP address and the network interface associated with the specific route in your virtual network. It helps you to troubleshoot routing issues by identifying the next network component. The VPN Troubleshoot is a feature helping diagnose connectivity issues related to Azure Virtual Network Gateway and VPN connections. Packet capture is a feature analyzes the packet and diagnoses of the network problem. And this is an extension of the virtual machine and allows you to check packet without connecting to the virtual machine. And the connection troubleshooting investigates the problem and identifies the cause when a connection fails. And lastly, NSG flow logs provide a detailed logging of network traffic allowed or denied by NSGs. They capture information such as source and destination IP address, port, protocol, and action taken by NSG's rule. And these logs can be used for auditing, compliance, and security analysis purposes. So that's all for the explanation of the Network Watcher. Lastly, in Section 4, I'm going to introduce official documentation, learning path, and pricing calculator. Azure documentation is the official document provided by Microsoft. It covers various aspects of Azure, such as compute, storage, networking, and more. The documentation includes a wide range of topics, including the tutorial, the quick start, and the troubleshooting tips. It regularly updates to reflect the latest features so you can access to up-to-date information. And next, Azure Learning Path is the set of educational resources given by Microsoft. Each learning path typically consists of the series of the module that includes the instructional videos, hands-on labs. The learning paths are aimed at a different skill level, from beginner to experienced cloud professional, and they are often tailored to specific roles such as Azure Administrator, Developer, Solution Architect, and Data Scientist. And lastly, the pricing calculator is a tool which you can estimate the cost of Azure services before you commit to purchasing them. It's designed to help potential and current customers of Azure calculate cost. And you can select and configure Azure services, including the virtual machine. And you can customize them according to the region, tier, support option, and other relevant parameters. You can save your estimate or express them in the various formats, and which can be useful for reporting or further analysis. And thank you for staying with me throughout this course. I also offer courses on AWS, Google Cloud, and Microsoft Azure. Stay tuned as I will expand my offering in the future. I would like to conclude the Microsoft Azure Fundamentals AZ-900 preparation course here. Thank you very much for your attention over this period. I am sincerely looking forward to the opportunity to meet you again.